here we are. We're at the end. We're in the 8.0s. 9.0 is the conclusion of my personal comments. But for all practical purposes, I'd say probably 75%, and I'm being conservative. These heads are ready to ship and go out the door, and rightfully so. We have paid attention to detail on everything. And these are a hell of a set of 186s. Back in the day, I'd say about 18 years ago, these heads would have cost somebody $3,000 to have got done. I know, because I was doing them back then, and that's what they went for. If you look at the CC volume of the head versus the flow numbers, even by today's standards, except on the exhaust side, because on the exhaust, that's where the aftermarket companies have gotten better by raising short turn height and stuff, adding more material. It'd blow your mind. Now, Mr. Imhoff has agreed, once he got the heads there, I'm sending them to him unassembled. He's going to carry them somewhere on a flow bench, something to either an SF600 or equivalent, and get the flow numbers, and he's going to post them. Or he's going to send, as he said, he had never posted to YouTube, sending me the tape in which I'll post the results that he's got, regardless of the outcome, because I don't hide behind nothing. My work speaks for itself. But this is the point right here where I kick in. To me, they're not done. Now, I'm sure y'all got to know me through the videos. You've seen a lot of my personality, and I'm sure you probably figured out that I have OCD. But my OCD is in another way, and it costs me money. Believe me when I tell you, I don't have much money. I barely survive, but we won't go into that. Sorry a second. My door just flew open, that wind caught it. Anyway, I get in there, porting cylinder head, and it's like, I can't leave this undone. I can't, this wrong. I've learned to control it some over the years, because if you don't, the next time I turn around, you know, I've got all these irons in the heads, and when I split the money that I'm working on these heads right here, I'll tell you, and I know you're not going to believe me, I've made about $5 an hour. That's right, $5 an hour. I charged Mr. Imhoff $800 to do these heads and threw in the intake manifold on the deal. There's a reason why I did that, but once again, I don't want to get sidetracked. The main thing here is to see, I'm almost done. What could possibly be left? You got to finish detail. Okay, when the valve job was done, the chambers are fully ported and everything. It leaves what's called machinist ridge. Now, to put it mildly, what I'm talking about is, here's the valve in the head. Here's the combustion chamber. When the stones go in there and they do their grinding, here's a stone. It might take more off one area than the other. Sorry about that. And what it does is it'll leave a ridge in certain spots. When you take your hand and run across this chamber, you'll feel this big lip. It might have a big lip here and a little one there, and then maybe none. If I could pull it out, it might have none here. Okay, the problem is when that valve starts to lift off the seat, guess what? The airflow starting to come out, it hits that ridge. Now that's going to cause a vortice or turbulent airflow right there, all right? On this side it might not. Anyway, the machinist ridge is that ridge you feel like if you buy a brand new in the box set of aluminum heads. Good example. This is one of the next projects we're getting ready to do. This is the Pro Max 360 big block Chevrolet head. Alright, now when I order these from Pro Max, I specifically say, do not do the valve job, don't touch the guides, and because I don't like the finessing that they do, and it's not that the finessing's bad, it's just not like how I like it. Right here you can see in the chamber where the machine went in there and cut that, these big giant gulps and ridges in it. Well, It interferes with the airflow of the head, not to mention it leaves sharp points in the chamber. As I've told y'all, any sharp ridge or point is a spot where heat builds up quicker and causes detonation, which the description of detonation, the real description, is a sharp point where heat accumulates, causing a secondary flame. Here's your spark plug, getting ready to send the flame across, and then over here, here's a sharp ridge, another flame is started. So you got a flame front going this way, a flame front going this way, boom, they collide in the center, and you have detonation occurs. The combustion chamber pressure jumps from 500 pounds to 1,000 pounds when this happens. So we got to get rid of the ridges for two reasons. Number one, mechanical, which is detonation. Number two, the obstruction of flow. Now, just where the valve job is done, where that stone hits, leaves that ridge. More on this in a minute. I'm going to do one on this tonight, our introduction for my fine man in Canada. He's actually in Canada and driving all the way here personally to meet me, for me to hand him the heads, and I love that kind of stuff. But anyway, these have ridges all around them in certain spots, so we're going to go in there on the chamber, get rid of the ridges. But first, we got to finish up the last part, which is where I took the line and scribed the line mathematically, and I got to go in there and pull it too. Now, I'm going to try to get you in here close to show you exactly what it is I'm going to do, how I grind to it. Then we're going to do the chambers and clean that up and take the machinist ridge out of there, okay? And then, to conclude it, we're going to have the pickup point. So let's get on in there and look exactly at what I'm going to be doing inside the port, pulling it to the lines. I'm going to study on this exhaust port right here. Big feet again, sorry. Alright, and let me see if I can zoom in. You know, what purpose of trying to see that line, I might be able to hit it better on this angle here. Alright, now I'm going to try to point that line out to you and let you see what it looks like. Alright, and I can see it. I don't know if you'll be able to, but the line is right there. Now, let's look at an intake port. And that's going to be kind of hard, y'all. I had a bulb pop out on my bench. That's going to be an all-day job to replace it. But anyway, I think you can see it a little bit better. This is the short turn of the intake. Now, look at this 70-degree seat right here. Yeah, or 70-degree angle. It pulls in. There's my line right there. So look at all this goop. I've got to go in there and look. It's on the sidewalls right here. It's bigger here on this side a little bit. I got to go in there and chop that, because if you take your finger and roll, it's like we got a really nice short turn where I went in there and I took my cloth and pulled it down. But now where I redid the valve job, look at that. So, yes, Yank, I know the first thing you're going to be asking me here, this is especially for you. Yes, they didn't enlarge the 202 for the intakes either, just like they didn't do for the damn exhaust. And I had to go in here and I had to enlarge the intake, open that son of a gun up, and see, there's the ridge, the proof that they didn't enlarge the valve right there, bigger than life. So my pointer is pointing right at the line. Let me try to give you another angle here. I think actually without that light in the way I might be better. All right, see the line? Yeah, you can see it right there. All that area past there's got to be chopped and pulled down, because what if I don't do that? I'll tell you what if I don't do that. Then instead of having a 202, I might as well kept the damn 194 in it. After all that bow work and all that chopping, that last little bit could probably make as much as 10 to 15 CFM on mid and high lift flow. That much. So while most places will go ahead and send it, this is what Headbytes calls, I got to reset the bowls. That's after the valve job, after the porting, coming back in here and re-chopping that out, pulling it right up to the line. Now, right here is part of a machinist ridge. I think you can see it. Yeah, I can see that right there. There's a little ridge, and you can feel it. That one ain't too bad, about 15 or 20 thousandths. But if I don't get rid of that ridge, when the valve starts to open, the airflow is going to hit that ridge and start the turbulent mixture or the vortices. So we got to reset the bowl, re-chop all that and pull it in. Then I'm going to put dummy valves in there and go in there and pull them ridges out, which on the exhaust means I'm going to have to go back in there, re-stone it, re-polish all this area out right here. That's right, it's a lot of work I got to do after I chop that, because see, it has to be all polished back to the 300 grit finish that I put on it and pull that in. It's a lot of work, but you know what? To really get the most out of a head and to make one perfect, these are the things we do. So anyway, I'm going to go ahead, I'm going to start chopping, I'm going to show y'all how I do one intake and one exhaust, and then I'm going to stop. But now there's one question left that I wanted to answer a reader.